Hi, this set of videos is going to go through the Chapter 1, Sections 4 and 5 notes. We're on page 1 at this point. To begin the chapter, or to begin the section, angles were defined. Probably the most important aspect for the angles is that the sides of the angles are rays. This is important to know. We call the shared endpoint for these two rays the vertex. So there are three ways to name angles. The first way is to name it using three letters. When you do this, the middle letter needs to be the vertex, and then the other two letters need to be one from each side of the angle. So in this picture right here, using letters, you can see that we could name this angle ABC, we could call it ABD, and then of course we can reverse angle DBA, angle CBA. You'll notice that in the script that I use, angles can be seen using this symbol, but they can also be seen using, I will handwrite them using this symbol. I tend to put this on here so that it doesn't look like a less than sign, which it sometimes does when you make it by hand. The second way that you can name angles is by using the vertex letter only, but you can only do that if no other angles share the vertex. So in this picture, because this is a single angle, that vertex is not being shared, we can call that angle B. Whereas in this other picture, I can't call either of these angles angle M because that vertex is being shared by the two angles. So I'd have to use three letters, or I'd have to use the numbers that are here. And that's the third way to name an angle. You can use a number. The numbers that you write, again, have nothing to do with the measures. It's arbitrary what you choose. I choose to call this one 1, or 2, pardon me. Over here I call this angle 1, and this is angle 3. Okay, so again, the three methods are listed here for this picture. And for this picture, you've been asked to give another name for angle EMQ. And so your possibilities for EMQ would be to say it's called angle 1. It also asks you to give three other names for angle QMD. It's a good idea when you're deciding what angle to look at to actually read the letters and outline the angle with your pen so that you see which angle you're talking about. Again, QMD. So another name would be angle QMC. Notice the vertex is in the middle. We could also call it angle 3. We could also call it angle CMQ, or even angle DMQ. Okay? So keep in mind that you can reverse the letters, and notice in each of these situations the vertex is in the middle letter. Okay? Also keep in mind that an angle breaks a plane into three regions: the interior, on the angle, and the exterior of the angle. So if I draw an angle here, and let's call this guy angle ABC, this region inside would be considered the interior of the angle. All of the information outside would be considered the exterior of the angle. And of course, those points that lie on the angle would be part of the angle itself. Now, another thing to think about while we're looking at this picture is the idea of the sides and the vertex of the angle. So before we switch to page 2, my question for you is, what are the sides of this angle? Well, the sides are rays, so the two rays that are making up the sides would be ray BA and ray BC. Be careful to use proper notation. Again, sides of angles are always rays. Okay, we're moving on to page 2. On page 2, you'll find that the types of angles are listed here. We have acute angles, which are angles which measure less than 90 degrees. Again, the unit of measure we're using is degrees. A right angle measures 90 degrees. An obtuse angle lies between 90 and 180. And then a straight angle measures 180 degrees. I tend to not use this one very often because if we draw a straight angle, it's pretty much going to look like a line. Quick sketches of each of these type of angles would be an acute angle, a right angle, and to denote a right angle, we put a little square in the corner, and that denotes a right angle in a picture. An obtuse angle, this would be an obtuse angle, and then a straight angle would look like this, but boy, doesn't that angle look like a straight line? So most of the time we're going to talk about it as a straight line, but the important part is to know that it's 180 degrees from one side around to the other. It would be 180 degrees, and that will be important for solving. All right, we're moving on to page 3. Okay, on page 3, we meet some vocabulary. Angles with the same measure are described as congruent. And so we would say angle S is congruent to angle K. When we talk about the measures of the angles, we put a little M in front of the angle symbol. So this would be the measure of angle S is equal to the measure of angle K. Again, it's a way of saying that we're talking about the number rather than the object. Okay, so protractors are the tool that we use to measure angles, and it's not very clear in this picture, but there's a protractor here. Protractors will have a center point, and then they'll have a baseline drawn out. It can be a big baseline, it could be just a small little crosshair at where the vertex is, but all protractors will have it. Okay, so to use a protractor, and this is a much better picture, we place the protractor over the angle so that the vertex will sit at the center point and one side of the angle will be on the baseline. And then we measure from 0 degrees to the second ray. If necessary, we may have to extend the side of the angle to see where it crosses the protractor. And again, you would just use a straight edge to do that. In the picture below, you can see that angle DOC is measuring 20 degrees. We're using the inner scale because we used this baseline, which starts at 0. In the picture, we can also see that angle AOB measures 55 degrees. Since we're using this baseline, we use the outer scale of the protractor and read it to be 55 degrees. Okay, we are continuing on. Oh, and then it asks you to find, the measure of angle DOB. Again, we're using this baseline, so we're going to start with the inner scale. And we can see that on the inner scale, this angle measures 125 degrees. Notice I'm using the M to show that I'm talking about the number. And then angle BOC, well, there's two different ways you can find it. One way would be to actually take the protractor and use this as your baseline. Another way is to take the fact that on one of the scales, this is reading 20, where this ray is, and then on that same scale, this is reading 125. So you can find the measure of angle BOC by doing 125 minus 20, which is 105. Notice it works the same if you use the outer scale, where you would take 55, and over here this would be 160, and 160 take away 55 is also still 105. Okay, now we're really done with page 3. Hi, We're on page 4 of the note packet for chapter 1, sections 4 and 5. So we use protractors to measure angles and we use them to draw angles. So to draw an angle, you draw a ray, you line up the center point and baseline on the ray, and mark the corresponding degree mark on the protractor, then use the straight edge to draw the second side of the angle. So I'm going to take my protractor. I am going to lay, notice here on this protractor, this is the center mark, and the bottom acts as the baseline. So I'm going to go ahead and line those up, and then I'm trying to make a 75-degree angle. So again, since I'm using this baseline, I am going to use the inner scale. 75 degrees would be right here. So I make the mark, which unfortunately is running into my writing, but that's okay. And then I use the straight edge of my protractor to line it up. But I'm just going to go ahead and draw this much of the ray, and we'll have a 75-degree angle. I then move over here, and we've been asked to make a 120-degree angle. So because of the way I've positioned the ray, I'm better off putting my center point here and using the left side as the baseline. So I go ahead, I set up my protractor. Because I'm starting with this 0 line, I'm using the outer scale, and I want to go to 120 degrees. Oh, which is barely going to make it on the paper. I line up my protractor, and again, I just draw out a little bit of the ray, and that's 120 degrees. Now, it's asked us to go back to page 2 and use the protractor to draw examples of each type of angle. We're not going to do that for now, so again, be sure to check either in conference or come on by and just ask questions in class. At the bottom of page 4, you can see there's the angle addition postulate. And the angle addition postulate, I pretty much call it cousin to the segment addition postulate. You can abbreviate it with AAP. And again, that may come in handy in the future. So all that the angle addition postulate says is if I have these two adjacent angles, and I want to find the measure of the large angle, ADC, it'll be equal to the measures of the two small angles added together. Okay, we're done with page 4. Let's stop here.